Hi everybody, Mrs. Danielson here, and today we're going to learn about the law of sines. The law of sines is great, you're going to love it. It's a way of solving for a triangle that is not a right triangle, but using our trig to help us solve for it. So who knew up to now, but you could actually use trigonometry to solve for a triangle that is not a right triangle. But we do have a couple of laws that let us do that, and today we're going to learn about that first one, the law of sines. So right here you can see I have a triangle. It is not a right triangle, it's just an oblique triangle, and we're going to solve for the different parts of that triangle using the law of sines. Now the law of sines is actually a pretty easy law to use. This is what the law of sines is. It is that sine A over A is equal to sine B over B is equal to sine C over C. So it's just a ratio of the sine of an angle to the opposite side is equal to sine of another angle to its opposite side is equal to the sine of the third angle opposite its side. Those three ratios are all equal to each other. And what you're going to do is you just pick two of those, any two of those, and set them equal to each other to solve for something you don't know about the triangle. What you need to know to use the law of sines is from your triangle that you're solving for, you need to know three pieces of information to be able to solve for a fourth piece of information. So for instance, let's say we have our triangle. In fact, actually, I have a triangle written down here. Let's go ahead and take that triangle, and I'm just going to move it up so that it's where we want it to be. Let's just move it up here a little bit. And let's do another one and move it over here. Okay, so let's say we have a triangle, and let's go ahead and call it, well, we don't need to label it right now, but let's say we have a side, and we have another side, and we have an angle. So we have a side, and an angle. If we have those three pieces of information, then we're going to be able to use the law of sines to solve for the rest of that triangle. Another example would be if we know an angle, and an angle, and a side. Angle, an angle, and a side. Okay, so in those three cases, and in those two cases, we know three pieces of information, and that's going to help us solve for the rest of the triangle. So let's erase this one. So to use the law of sines, you need to know three things about the triangle. Okay, and at least one of those things has to be a side. And one of the three must be a side. Meaning, all three of those things can't be an angle. All right? Okay, so let's see how we're going to use this law of sines to help us solve for a triangle that is not a right triangle. Okay, so let's go ahead and we're just going to write a triangle here, and we're going to solve for it. Let's say this is our triangle. I can't promise this is drawn to scale. I'm just drawing a triangle. Okay, so let's say this is triangle A, B, C. Okay, so this would be side A, this would be side B, and this is side C. And we're going to solve for this triangle. Remember, solving a triangle means that we are going to know all the sides and all of the angles when we are done. And let's say what we know is we know that angle C is 30 degrees, and we know that angle A is 25 degrees. And let's also say that we know side C is 38.2. Okay, so we need to solve for side B, and we need to solve for side A and side B. All right. So to use the law of sines, what we have to have is we have to have one angle side pair. Like we need to know angle A side A, or we need to know angle B side B, or angle C side C. We need to know one of those pairs. So in this case, we know angle C and side C. So that means we're going to be able to use the law of sines. So we're going to use C and C, right? Those are the two that were given here. So we're going to use that pair to help us solve using the law of sines. They've given us angle A, but not side A. So that's going to be the other one we're going to use. Okay, we're going to use those two pairs, C and A. And again, we're using C because those two are given to us, 38.2 and 30 degrees. Angle A we're given, that's 25 degrees. And side A, we don't know that, so we're going to solve for that. Okay, so to solve for side A, you just cross multiply. Okay, so you cross multiply, you're going to get A sine 30 degrees is equal to 38.2 sine 25 degrees. Okay, so to solve for A, just divide by sine 30 degrees. Oops. Sine 30 degrees. Okay, so sine 25 degrees times 38.2 divided by the sine of 30 degrees, that's going to give you side A. Okay, so you put that all in your calculator. Okay, and you should get approximately, let's correct that there. You should get just about 32.3. All right, let's go ahead and write that up here on our little drawing. Okay, so we got that that is 32.3. All right. Okay, so there's still two things we don't know about our triangle. We don't know angle B and we don't know side B. Okay, well, we need to know angle B if we're going to solve for side B. Okay, angle B we can solve just because we know that a triangle adds up to 180 degrees. So let's go ahead and solve that next, right? Angle B is going to be 180 degrees, the total for a triangle, minus 30 degrees, minus 25 degrees, right? So that's going to be 180 minus 55. So that's going to give us 125 degrees. Okay, so angle B, we got right there, is 125. Let's go ahead and write that in our triangle. 125 degrees for angle B. So now all we have left is side B, and for that we're going to use our law of sines again. Okay, so we're going to use angle B side B. Okay, so we're going to use sine B over B. That needs to be in there because that's what we're solving for. And then the other pair, we can use sine C and C again, like we did the first time. Or now that you know side A, you can use sine A and A. Use either one you want to use to help you solve for B. I already used C and C, so I'm just going to use C and C again. Right? But you can use either one. Oh, let's go ahead and just write that out. Right? So we can just be totally clear what we're doing. We're using angle C and side C, but you could use angle A and side A now that you know both of those. Okay, so B is 125 degrees. Side B is what we're solving for. Okay, C is 30 degrees. And side C was 38.2. Okay, now to solve for B, you just cross multiply. So B sine 30 degrees is 38.2 times the sine of 125 degrees. See how easy it is to use the law of sines. Cross multiplying is great. Easy to do. Okay, and then divide by the sine of 30. Okay, plug that into your calculator to get the side B, what the length of that is, sine of 125 degrees times 38.2 divided by the sine of 30 degrees, and you get side length B, which is approximately 62.6. Hopefully that's what you got there. Okay, so let's go up here and let's put that on our triangle. Right, we got 62.6. Okay. Now, when you're finished with your triangle, take a look at it and just make sure it looks right. Right? The side opposite the largest angle should be the longest side. Okay, so 125 degrees is our biggest angle, and our longest side was 62.6, and it is. And the smallest side should be opposite the smallest angle. So 25 degrees is the smallest angle, and the smallest side is 32.3. So everything looks proportional and looks like it should. So we're feeling confident that we've done everything correct. Okay, excellent. All right, so that is how you use the law of sines. Okay, pretty nice, easy equation to use. We love it. And so great that we have a way to now solve for a triangle using our trig, even when it's not a right triangle. Let's do another one. Okay, here's triangle ABC. Okay, and we're gonna say that angle A is 41 degrees. Okay, side B is 89. Side A is 40, and we don't know side C. We know two sides, and we know one angle. Okay, now the thing to use the law of sines again is that you need to know one angle side pair. And we do have that here because we know angle A and we know side A. Okay, so we're good. Okay, so we're going to use angle A, side A, and then we know side B, but we don't know angle B. So that means we're going to use B and B as the other side of our equation. Okay, so angle A is 41 degrees. Side A is 40. Angle B, we do not know, but that's what we can solve for, given that side B is 89. Okay, so now you would plug that in and solve for the angle B. Cross multiply. 89 sine 41 degrees is 40 sine B. And just divide by your 40. Okay, so crunch that with your calculator. Do the sine of 41 degrees times 89 divided by 40. And what do you get? You should get a decimal number. You get about 1.46. Okay, approximately that, right? You'll get a bigger decimal than that. We're just kind of rounding. Okay, so now you would use your calculator and you do inverse sine to find the angle that has a sine of 1.46. But what happens is when you put that into your calculator, you don't get an answer. Instead, you get an error. The reason for that is because no angle has a sine greater than 1, right? They're all less than 1. Okay, so there's no answer here, right? You get an error. Okay, that doesn't happen. Okay, so that's okay. That's what's supposed to happen. If you got an error, you're good. Okay, that's all right. Okay, so what that means is there's no triangle with the given conditions. There's no answer. for this problem right here, okay? So sometimes that just might happen. You might not get an answer for every given triangle. And this is an example of one where that would happen. Okay, so that's using the law of sines. The law of sines is really easy to use. We love the law of sines, and it's so fun to be able to use trigonometry on a triangle that is not a right triangle. Now, there is one situation that occurs once in a while with the law of sines that you just kind of have to watch for, and that's the ambiguous case of the law of sines. And the ambiguous case, we're going to talk about that in a different video. Okay, so you'll have to switch now, if you're ready, to the video for the ambiguous case of the law of sines. Thank you everybody for watching, and enjoy using the law of sines.